slope and how to get the slope based on a picture or a graph. I sometimes like looking up the etymology or the meaning or history of a word. The word slope comes from the 1590s or so. The word slanting. Some have the word aslopen, which is to slip away or an incline. So in many ways, a slope is how a line is slanted or which direction it's sort of pointing. Some teachers will say that a slope is rise over run. You can argue it doesn't always rise. We often now say it's the change in the y value. In a graph, the y is going up and down. Change of y over the change of x. The x value goes in a graph left and right. It's this coordinate, left and right. So really we can describe this with a picture with arrows. It's trying to see how much up or down versus how much left and right something is changing. So to do that, there's a little minor thing we want to remember on a graph. Going up is positive. And going downward is going to be negative. Likewise, moving to the right is going to be positive. Moving to the left is negative. When we look at a graph, we want to get a point. Sometimes they give you the point, but we want to make sure it's a spot touching a corner on the coordinate. So right here or right here. We can't use a spot like this because it's not touching a corner of the box. So to get this particular slope, we're going to count how much up or down. So starting from the left, we're going to go up 2. And then we're going to compare it to how much to the right or to the left, and to the right 1. So again, moving up is positive and to the right is also positive. So we would say this has a slope, usually we use m, we have a slope of 2. We could in fact use the right point to start with. We would then go down 2 spaces to get to the next point. That's negative 2. And we would then go to the left 1, which is negative 1. And in the end, we get the same slope value, depending, it doesn't matter which side you start on, depending on whether you start on the right or the left. But typically we start on the left side. Most people start at the left. That's why they say run, meaning you always go to the right. Let's try another one. Sometimes your slope might be going or pointing downward. We can take a look at that. If I zoom in here a bit, once again my slope is how much up or down versus how much left and right. I have a point here that's touching a corner of the coordinate, and I have to keep looking, and then here's another corner. So starting from the left side, I'm going to go downward 1, 2, 3, 4 boxes. So down 4 would be negative 4. And then I'm going to move to the right 3. So the slope here would be negative 4 over 3. Now something interesting is if we pick any other point, say up here, and I go down 4, 1, 2, 3, 4, and then to the right 3, 1, 2, 3. When I connect those dots, it's going to be the same slope or the same slant. And we call that in math parallel. So parallel lines do have the same slope. We learned that perpendicular lines will have a slope that's an opposite sign and a reciprocal. But that's for another lesson. There are 2 special cases when looking at slope that are a little bit different. One is a case that says the slope is 0, and one when the slope is what we would call undefined. And we can show that and why one is 0 and why 1 is undefined. So if I have a vertical line, then I would really pick any 2 points. And again, we're looking at how much up or down versus how much left or right. So I can really count any amount. It's really like infinitely up and infinitely down, but we want to pick any number. So I'm going to go from this spot to this spot is down 2, minus 2. So then the second question is, how much left or right do I go? And left and right, we don't go any amount, so it's 0. As you know in math, we are not allowed to have 0 on the bottom. And so in higher math and calculus, we would investigate as it approaches 0, negative 2 over 0, what it would be. And we start to talk about infinity, but before then we don't use 0 on the bottom or on the denominator. So any number with 0 on the bottom, we call that undefined. And so a vertical slope, this would be 1, 2, 3. X equals negative 3 is the line. Vertical lines are going to have an undefined slope because they don't move left or right, so it will be 0 on the denominator. Likewise, we have a horizontal graph. A horizontal graph is going to go left and right. And we can ask those same 2 questions. How much up or down do we go? And it will be 0. However, how much left and right? You could really pick any spot on the boxes. I'll just pick 1. And so 0 divided by 1 is 0. So we would call this 0 slope, no slope. And so those are the 2 special cases when it comes to slope. But we count the change in y over change in x. And for those who are interested, you can kind of start to see how we get the slope formula. Let's show you how we get the slope formula. The slope formula says, I don't want that line. It says y2 minus y1. x2 minus x1. So again, we can see it's y is on top, the change of y over the change of x. That's really what the slope formula is asking. Let's say I go from here to here. So if this point is at 2, and 1, 2, 3, 4, 5, and this is at 5, and this is at 2, and this here is at negative 1. So if I start here at this point, I'm starting on we're going to look only at the y value, how much up or down it is. So it's at 2 here. And this one up here is at 5. So if we want to know how much of a distance or change there is, we would subtract them. And then if it's negative, we make it positive. By subtracting the top one, 5 minus 2, we're going to get 3. However, we could subtract 2 minus 5 and we get negative 3, and we just make it positive because in real life situations you don't have a negative height. But usually we'll take the higher number minus the lower number and we'll get a positive answer. Then we'll take how far from left and right did they travel. So from here we have negative 1 and here we have 2. So to find the distance between those, you could count them, there are 3, but we're going to take the number 2 here and subtract where it is over on the other side, negative 1, minus negative 1. So we still have to subtract it even though it's a negative, and minus minus, or subtracting a negative, becomes positive. And we can see that the slope is up 3 across 3. So the slope formula is simply creating a formula where you can plug in any amount. And they oftentimes will demonstrate without using any numbers. So if this coordinate is x2 and y2, And the first coordinate is the first point, x1, y1, meaning the first y coordinate. What I'm doing is I'm first checking how much height there is between the 2 points. Well, the height is determined by the y value, or the y place. So again, like we did a moment ago, we're going to subtract the y2 minus the y1, and we get this. Then I want to see how much left and right I go. And it's really going to be subtracting here to here, which is our x2 value minus our x1 value. Because here's our first x value, here's our second x value, we would subtract them. Here was our second y value, here was our first y value, we would subtract them. So subtracting y2 minus y1 just gives you how much distance there is between the 2 points vertically, and then x2 minus x1 is how much distance there is between the points horizontally. So hopefully we understand slope a little better, but at least we can understand how we count how much change there is up or down divided by how much change there is left and right.